Alright, our last form of quadratic equation that we're talking about this time, it is intercept form, which is going to look like this fella that you see down here. Y equals x minus 3 times x plus 1. And so now what we're going to do is we are going to take a look at what we can find from this. So remember, we've now gone through all three forms, vertex, standard, and intercept. Vertex and standard you found, and now we have intercept form, which you'll also hear sometimes called, and I'll probably slip up and call it this at some point in the video, it's called intercept form or factored form. Both of those are straight legit names for this thing. So intercept form or factored form, whichever you prefer. I'm going to attempt to stick with intercept form, but I'll probably end up calling it factored form at some point. So remember, we have all these key features we're looking for. We can find the vertex, we can find the axis of symmetry, which is an equation. The vertex is a set of ordered pairs. We can find the y-intercept, where it crosses the y-axis, and the x-intercepts, where it crosses the x-axis. And since this is called intercept form, I bet you can guess what plays a key role in this one. So intercept form allows us to find very easily the roots of a quadratic, and that is really the primary use of this, is to find the roots. Now we can also find the vertex and the axis of symmetry, but just as with standard form, there's a little more work involved with those, and the thing we're most interested in from this is going to be the roots. So here's what intercept form looks like. Y equals a times quantity x minus p times quantity x minus q. Notice the p's and q's get kind of confusing there, but that's the notation that we use. Sorry. For the roots, all we have to do is we find out what p is, we find out what q is, and then my roots are just p and q. So just like with the y-intercept on standard form, the x-intercepts are super easy to find if you have intercept form. Now the vertex and the axis of symmetry, this is just like standard form, where we have to do a little bit of figuring to get these. So what we do to find the x-coordinate of the vertex is to take p plus q and then divide by 2. And that gives us our x-coordinate for the axis of symmetry. This is actually pretty clever when you stop and think about it, because my roots, which are p and q, are going to be separated by the same distance from the axis of symmetry. Since all quadratics are symmetrical, the vertex has to be exactly halfway in between p and q, or the x-coordinate of the vertex anyway. And so if we just take the average of p and q, that tells us exactly the halfway point between them, and so will tell us our vertex. So that's actually a pretty clever way of getting to that. Once I have my x-coordinate, just like with standard form, I can substitute that back into my equation in order to find the y-coordinate of the vertex. So let's do it. There's no better way to figure out how this works than to actually jump in and take care of it. So here we've got our intercept form equation. We're asked to find the roots, the vertex, and the equation of the axis of symmetry. So our general form would be x minus p, x minus q, with a coefficient of a. And I need to look at my equation and find what all these guys are. So from this particular one, I can see that a is 3. P is going to be the opposite of whatever's in the first set of parentheses. So the opposite of negative 2 is going to be positive 2. And then q will be the opposite of whatever's in the second set of parentheses. So the opposite of plus 5 would be minus 5. And so now what I'm going to do is find the roots from this. And to do that, I just remember that it is going to be p, so 2, 0, and now I just use q, negative 5, 0. And so those are going to be the roots of my equation. Easy as that. My vertex, well, not so easy. We got some figuring to do. So to find the x-coordinate of the vertex, I take p plus q divided by 2. So in this case, that would be 2 plus negative 5 over 2. And so that gives me negative 3 over 2, or negative 1.5 if you like decimals better, which frankly I kind of do. So negative 1.5 is my x-coordinate. My axis of symmetry then would be x equals negative 1.5. And now all I have left to do is to substitute that negative 1.5 back into my equation, just like I did before with standard form. So I'll say y equals 3 times x, oh, not x, excuse me. Sorry, you ever just lose where you're at for a second? Totally did that. Substitute in for x that negative 1.5, and then it's going to be minus 2. And then again, substitute in for x that negative 1.5, and in this case, we're going to add 5. And this is perfect work to put into your calculator. And after a break to throw that in a calculator and see what we get, I am getting for that value y equals negative 36.75. So yes, calculators are your friends on this. So the vertex would be at negative 36.75. And so notice that from relatively calm numbers, we get kind of an awful looking vertex from this. That can happen. That's legit. So be aware that because of all the calculations going into the vertex, you might get something ugly there. That's okay. That's nothing to panic about. So there we go. That's intercept form. Let's try another one because these guys can get complicated quick when calculating that vertex. So here we go. Same thing. Find the roots vertex equation of the axis of symmetry. I'm going to write this guy out and find all my individual parts, my parameters. And so I can find A is the number out front. It's going to be 4. P is the opposite of the number in the first parentheses. So negative 7 means P is positive 7. And then Q is going to be positive 2. Again, the opposite of whatever's there. So now I've got positive numbers for all of these. So my roots are just going to be at P 0, so 7, 0, and 2, 0. So again, finding the roots, it's as easy as taking the opposite of whatever's in those two numbers right there, and that's your roots. So that's the nice part about intercept form. If we're pressed, we can find the vertex. So to find the x-coordinate, I'm going to do p plus q over 2. And so I get 7 plus 2 divided by 2 is going to be 9 over 2, or if you're a decimal kind of guy or gal, that would be 4.5. So now that I have that x-coordinate of 4.5, I know my axis of symmetry is going to be at x equals 4.5, and now I just have to substitute that back in to the equation. So y equals 4 times 4.5 minus 7. So I just replace the x with the 4.5, and again right here 4.5 minus 2, and then we're going to take that and put it into the calculator. And this one comes out to be negative 25. So when I crunch all those numbers, I get y equals negative 25. And that is the y-coordinate for my vertex. Just like that. And so now, again, I've found all the parts that I can find from this. So to recap, we have all our parts of a quadratic function: vertex, axis of symmetry, y-intercept, roots, and we have our 3 forms of equation. Here we're focused on intercept form, which allows us to find the vertex, the axis of symmetry, and the roots. And the easiest one to find is the roots. This thing takes the form y equals a times x minus p, x minus q. The roots are just p and q, and the x-coordinate of the vertex is p plus q divided by 2, and then we substitute that back in to find our y-coordinate, very similar to how we did with standard form. And just as before, what we're going to be doing is we're going to practice finding these, and then we're going to move towards graphing these functions.